Okay, so you went through that worksheet and we talked about antiderivatives, but we're going to need to know some notation with these antiderivatives, okay? And we need to kind of talk about what it means to be an antiderivative, okay? So you will need to jot a few things down, whether you want to do it on this piece of paper or in your notebook, okay? Make that decision right now. 3, 2, 1. Number 3. Yes.
Oh. Bring back. Also, enjoy half court.
Not like great.
Can't find my map though. Oh wait.
Okay.
Yes. No.
So, what I'm going to do, because we're going to talk about our function f, I'm going to talk about a capital F and a lowercase f. And that's what we're going to talk about with our antiderivatives. Okay? So, capital F is the antiderivative of little f if, when you take the derivative of the antiderivative back to the function.
Cross out the derivatives, we love to F with and.
Well, not quite. Okay? So this is basically what you did on your sheet, right? You thought, okay, what function, if I took the derivative of, would get me here, right? Okay. Now, what this means is this. This means, what is the antiderivative of f with respect to x? Okay, so instead of saying, what is the antiderivative, okay, this is the notation. And on your sheet, you figured out what that function was.
Snake looking dude.
Okay, this is actually called an integral. Called an integral. Okay, now, I'm not quite done up here. Okay, I want you to go, but I want you to refer back to your sheet, right? What's the derivative? I'm going to go to number 1. What's the derivative of 3x? 3. Is that the only function that has a derivative 3?
No.
Okay, give me another one.
3x plus 3, 3x plus 4, 3x
Okay,
plus
give me
5.
another one. Because you were the one saying that no.
Would negative 3 extend negative 1?
No, it would not. Because that would be 3x to the negative 2, okay? But 3x plus 4, 3x plus 5, 3x minus 17, 3x plus 21, 3x plus 1,000. Oh, what's true about the derivative of a constant? It's 0, okay? So what's going to happen is when we take the antiderivative, we know that there could be a constant added to it, to where when you go backwards for the derivative, that would go to 0.
How do we find that constant?
Plus or minus?
We don't yet. Okay? If I am just asking you for the antiderivative, you're going to tell me what the function is, plus c.
So we're not gonna find out how to do that.
The only way that we could figure out what that c is if we knew something about our original function, like a coordinate.
So what are we actually using?
Oh, buddy.
Oh,
Sorry.
outside. We don't use it. Can you list a few
Okay.
things? Take us down.
so much.
You say so much, but it's not one thing.
Like Brady, what you do this week is so much.
Okay,
So,
so when we come back from winter break, we're gonna talk about area under the curve.
Oh no.
But we already did that in physics.
but then like,
Kind of.
isn't the antiderivative just
Yes, which there's so much that you don't know, so I can't really tell you more about that, but this is gonna help us find the area under the curve. It's also gonna help us when we're working with position, velocity, and acceleration. Okay? Now, stay with me here, stay with me here. Okay? Stay with me. If we take, okay, let's talk about this. Okay, this means take the antiderivative of the derivative.
So we get.
So we get the function. Right? Does that make sense? The antiderivative and the derivative kind of are
Are you taking the derivative of the antiderivative of the function?
this is taking the antiderivative of f prime of x.
So if you take the antiderivative of the function, you get.
What you just said is this.
Okay, this is not really.
like the derivative of the antiderivative of the antiderivative?
Yes.
Ah, I see it.
Okay.
Well,
Okay, so the top one you're taking, what isn't the base f the antiderivative?
No, S.
okay, so how about I just do this? Does that look better, just like in general? If I have the antiderivative of a derivative, we're going to be left with the original function.
Yeah, that makes sense.
Okay, if I take the derivative of an antiderivative, we're going to be left with the original function. That's all I'm saying. Okay? So let's talk about a couple things.
Oh, she made me on a slide, it's not cool.
There's one. Only one of them.
What is the derivative of a constant? Zero. So if you have the antiderivative of 0,
You get C.
you get a constant. Excellent.
Okay.
Oh, wait, what is dx?
That is what you are taking the antiderivative with respect to.
Oh, I get it.
Okay? Okay? So what is the derivative of kx plus c? Okay.
Okay.
Okay. So if we have the antiderivative of a constant k, then we have kx plus c. All right, so if you have the antiderivative of a constant, you're basically going to tack an x onto it for the antiderivative. Okay. All right, so let's talk about this. You did a lot of this on your sheet. How did you figure out what to do? Like, go and look at when you had the antiderivative of x squared, x cubed, x to the 4th, x to the 27th. What was your thought process, Alan?
It was like 1 over n plus 1 times x to the n plus 1.
So you increased the power, right? But then you had to multiply it by this for when you go to take the derivative to go the other way, right? Excellent. That is the power rule for antiderivatives. Okay? And that, ladies and gentlemen, is what we are focusing on today. we're gonna do some examples.
Notes.
Are we gonna have to chain rule these two?
That's something.
Chain rule gets a little complicated with, not in the fact that it's difficult, but it's not, we can't call it the chain rule and do it exactly backwards, okay? The chain, instead of the chain rule for antiderivatives, we're gonna learn what's called substitution. Typically, I would teach it before winter break, but we have 1 week less this semester than we typically do, and so that's what we'll start next semester with. Okay? So let's practice some of these. Are you ready? Okay. I would like the antiderivative with respect to x.
So 2/5 x times 1/3 x.
Okay, so we're going to increase the power by 1 and divide by that number. Same thing here. Increase the power by 1. Oh, whoops. The power was. Final answer?
Yes.
Let's see.
Thank you, John. Let's see.
Dang, that was clutch.
Johnny?
What if the first doesn't have a constant? Because they don't know. Could still be zero.
It could be 0, it could be 1. Really, any number here would satisfy, like if we were to go backwards, if we were to take the derivative of this, it wouldn't matter what our constant is. It could be anything. So technically we have an infinite number of answers, right? What that C is going to be important for is if we know something about our original function, we can actually find what that value is. Okay, and that's something that we'll do tomorrow. Okay. What should we maybe do with this?
Rewrite it.
Okay, just like power rule with derivatives, power rule with antiderivatives, we should rewrite so you have x to a power. So I would rewrite this x to the negative 2/3 power. Now let's apply our rule. What happens when we add 1 to our power?
1/3.
So then we would multiply by 3 over 1.
No, we're dividing by 3 equals 1/3, so 1/3.
You could either think of dividing by that power or multiplying by the reciprocal if you'd like.
Kind of like
Split. Alright, how about this one? Okay. Please tell me what the rewrite would be.
X squared to the 1/3.
Yep, and how do we do that?
X to the 7/3.
Ah, thank you for remembering your rules of exponents. We have to add those numbers together. So x to the 7/3 dx. So our antiderivative, x to the 10/3 times plus c. Thank you. A little food for thought. If you forget the plus c on your answer, technically it is incorrect. So can you imagine forgetting the plus C on every single question on Friday's quiz?
Technically, what is C to zero? That is.
But we don't know what C is. It could be 0, but it could be 321.72.
We do know it could be zero. There's very small.
Where's the very large possibility, like, in relation to every single number?
So, if technically it's incorrect, does that mean you're going to take a point? Yeah. Could you take off like a quarter mark?
I will take off
Whole thing.
some points. It won't be full points. But if you get every single antiderivative correct except the plus C, you will not get 100%. How's that?
You'll get a 99.
Oh, darn it. What if my best grade? What if we forget the plus C on one? Wrong still?
You'll find out. Don't forget.
All right, let's hope for it.
Let's see on top of our
Okay, so I keep stepping on this.
There's things that we do a plus C on every single, right there, a plus C. Was there a minus?
Plus C on everything. Yeah.